Good morning, everyone, and welcome to the Batteries for Defense webinar. I still see that people are joining us and numbers are going up, but this is a very brief session, so we'll make a prompt start. I'm Nicoletta Piperidou from KTN, working in the Clean Energy and Infrastructure team, looking primarily after batteries. I'm sorry for keeping my camera off this morning, patchy internet, so keeping camera off helps with the sound. Thank you very, very much to all of you for joining us. We have an excellent session coming up. If I can just move on to the practical aspects for today. So as you'll see, everyone is muted throughout the webinar. You can use the Q&A box for submitting questions, and please use the chat box for networking and if you have any technical issues. It was great to see so many of you interested in the topic. We've had over 300 registrations for today, so please write to us in the chat box where you're joining us from and just say a quick hi. We look forward to hearing from you. This session will be recorded and you'll be receiving the recording. So look forward to hearing more later on. If we move on, our agenda for today, shortly after a brief introduction, we have an excellent lineup of speakers. Darren Browning of DSTL will be covering opportunities and technical requirements for batteries in the defense sector. Bethan Warby of BAE Systems will be looking at practical case studies, and all this will be followed by a lively Q&A chaired by our own Hazel Biggs, defense and security expert from KTN. Who we have today in the panel with us. So I'm also joined by my colleague Sheena Hindotsa, materials chemistry expert from our chemistry team. She's looking after chemical supply chains. Sheena is co-hosting the series with me. Sheena, would you like to say a quick hi?
Morning, everyone. Thank you for joining us today. It should be a really interesting session and hope you enjoy it.
Thank you. Also with us, Anna Wise, Head of Batteries at Innovate UK. Anna, I'm not sure if you'd like to say a quick good morning to everyone.
Yes, good morning, everyone. It's great to be with you all this morning and hope you enjoy the session.
Thank you. Also with us, Tony Harper, Challenge Director at the Faraday Battery Challenge. Good morning, Tony.
Morning, everyone.
Fantastic. If we can just move on further. This is just a quick snapshot of the current Innovation Network portfolio. As you can see, we're looking towards a very diverse mix of topics, so ranging from battery systems, the Innovation Network of today's session, but also looking after decarbonising ports and harbours and hydrogen economy, quantum technology, robotics, a very, very broad network of networks. There we are. If we can move on. So just a quick snapshot of what this Innovation Network is all about. I'll be popping in some links in the chat box for you to sign up and hear more about us. But this is just a snapshot of the essence of this Innovation Network. It's all about opening new markets for the battery industry, promoting innovation, and helping decarbonize a wide range of end users. So today we're looking at defense. Through the series, we'll be also looking at batteries for the rail industry and batteries for the maritime industry. So batteries, as you all know, can be used in a very diverse end-use sectors. So we're starting with these three sectors, but we're open to suggestions. If there are other topics you'd like us to look at, please do let us know either via chat or via email, and we'd be more than happy to pick up your suggestions. So if you think of other topics we should be exploring, please do get in touch. Before we move on to today's agenda, I would like to share some sad news with you. I'm hoping actually that those of you who knew Nick Carpenter have already been advised of the sad news. We sadly lost Nick earlier in December, and we just wanted to say a few words about Nick, because Nick was leading this cross-sectoral activity. He was there from the beginning, and he would have really liked to be here with us today. So I will pass on to Tony, who will just say a few words about Nick. Thank you.
Yeah, thank you, Nicolesh, and sorry, folks, if I crack up a little bit. I'd known Nick for what must have been over 10 years when I was leading research at Jaguar Land Rover. We were doing our first low carbon vehicle project back in around 2009, and one of my guys said, "Tony, you got to come down and meet these crazy people in Silverstone. You're going to love them." And we went down, and it was Delta Motorsport, and Nick and his colleagues in a small team at the time, and I think they were a subcontract on that project. And not only did they share with us what they were doing on our project, but also talked about all the crazy ideas that they had for their business. And to cut a long story short, Delta Motorsport were partner, and I think on just about every major collaborative research low carbon vehicle project that Jaguar Land Rover did since, and in fact are still to this day working with Jaguar Land Rover and others. And the reason for that is that they really embodied the business of taking the nimble expertise and mindset of motorsport and applied it to working with bigger companies, and rather than just talking about it, those guys did it and made a business out of it. And not only that, but Nick put as much effort into working for the promotion and development of UK PLC as he did for Delta, perhaps more so. He's one of those folks that you wondered how he found the time to do the day job, because he was so dedicated to developing the capability of UK PLC and promoting the capability of UK PLC at home and abroad on the subject of low carbon transport technology. And he was always, he would always support events like this or delegations abroad or round tables with ministers or whatever in support of promoting the mission. So when we needed somebody, in this case, two people actually, Nick and Kevin Brundish, it didn't take too long for us to decide who we would like to lead what was then the cross-sector battery group and is now the Innovation Network. So, we asked Kevin and Nick, and after a period of, making me snivel and grovel in the best possible way, they both accepted, and that was just really testament to what Nick did. So in summary, not only was he did he do all the things I've just said, but he was a pioneer, an entrepreneur, an engineer, and a gentleman. He was an absolute gentleman, and as Nicoletta said, he is sorely missed today. He will be sorely missed forever, I think, in this endeavour. And it's only right that we dedicate not only this session, but I guess all of the activity that we do from here on in to Nick's memory. Thank you.
Thank you very much, Tony. Lovely words. I couldn't have said it better myself. Thank you so much. I will now pass on to the formal agenda for today. I would like to welcome Darren Browning of DSTL, who is Senior Technical Lead on Power Sources. He manages and performs research into a range of power systems for all three MOD services, but has recently specialized on the land systems. So Darren also leads on a range of international collaborations, including chairing the NATO Land Capability Group Power Team of Experts. So over to you, Darren.
Good morning, everybody. Thank you for the introduction, Nicoletta. As Nicoletta said, I'm Darren Browning from DSTL. For those who don't know DSTL, we're the Defence Science and Technology Laboratory, a part of the UK Ministry of Defence. I'd officially like to thank KTN for this chance to talk briefly about battery defence, some of the challenges we face, and perhaps how you can help us. Next slide, please. Oh, I've got control. Yes, I guess as an introduction, I guess the main question is really, why is defence interested in batteries? Well, batteries are a key enabler of many defence capabilities. The battlefield is becoming more electronic and more digitised, and with platforms becoming more electric. There's an increased need for power and hence batteries, and I expect a growth in electrical energy consumption. We therefore need more batteries and better batteries to prevent an unacceptable growth in weight. It's worth noting that defence is no longer the major investor in battery development. And therefore we need to, I guess, adapt and adopt commercial technologies where possible. And if we can, we should leverage civilian research and seek dual-use technologies. Although it's perhaps worth noting that defence does require some niche research, and where the civilian market isn't really addressing the need. And this is maybe for very high energy primary batteries and maybe thermal batteries. Sorry, next slide, please. It's worth noting that some of the potential markets or applications for defence batteries. For example, in the land domain, there's a consideration for hybrid electric vehicles. Soldier systems are becoming increasingly electrified and perhaps moving from primary batteries to rechargeable network batteries. Unmanned ground vehicles and maybe battery powered or perhaps hybridized. And energy storage could be a key part of future base infrastructure to help improve efficiency and allow the introduction of renewables to help mod meet its net zero targets. In the maritime domain, there's need for large batteries for surface ships, both to enable new capabilities and potentially to hybridize with the prime movers to maximize efficiency. Batteries might also be useful for fast boats, that can be quieter and electric, and there's going to be increasing use of unmanned platforms, both underwater and surface platforms, and many of these will be battery powered. In the air domain, there's increasing use of UAVs and manned aerial vehicles, both fixed wing and rotary wing, and the rotary wing platforms such as quadcopters are a particular challenge as they're power hungry and tend to lack endurance. And batteries are also required for emergency and backup systems on manned aircraft. And then, as I mentioned earlier, there's this need for ultimate performance from some specialist batteries, such as thermal reserve batteries, I guess chosen for the very long shelf life of management and the very high energy primary batteries. Yes, sorry. Yes, I know perhaps it's obvious, but defence isn't really a single application and doesn't have a single set of requirements. Our battery targets very much therefore depend on the application. Our requirements are broadly similar to the Faraday targets, but I think where the differences lie is in the acceptable compromises. We all want a battery that is lightweight, cheap, safe, high cycle life, has high energy and high power. It's impossible to get that in a single system. Where I think defence may value some parameters perhaps higher than civilian applications or accept different compromises. Temperature of operation is very important to us. However, there's no single temperature range defined. It depends on the equipment's intended use. For those interested, Defence Standard 0035 is a useful resource. It lists the typical temperature range and tests for different environments such as hot and dusty, hot and wet, cold and wet, etc. For example, temperature range for military batteries may be somewhere between -20 to +70, and perhaps colder for some applications. I think one of the tricky balances requirement managers must make is ensuring that equipment is robust, but not over-specifying and hence building in unnecessary cost and weight into batteries. It's worth noting it's not just the operating temperature that's important, but also storage temperature. It's not uncommon for pallets of batteries to be left baking in the sun for a number of days. Performance is very important for military capability and may outweigh cost or cycle life in some cases. Well, that's not to say that mod has bottomless pockets. And I guess one extreme of this is the acceptance of very high energy primary batteries that have an incredibly high through life cost. But some of the questions we must ask is, what is the cost of the battery compared to a platform? We can typically tolerate a high cost battery on an expensive platform that we have only a few of, rather than in lower cost items we have thousands of. And then what is the price of overmatch and having that battle winning edge? If a better battery can help win the battle, then we should consider it, even if it's expensive. For most land and air systems, weight is perhaps more important than volume, but in the maritime domain, and especially for subsea, volume is usually more important. Military batteries are also likely to need higher shock and bump tolerance than commercial ones. Another important aspect of the battery level, maybe rather than at the cell level, is electromagnetic compatibility. There can be a lot of RF in a military environment, and we can't have batteries falling over due to sensitive electronics. We also obviously need our battery to be safe and reliable. Next slide, please. I thought it might be worthwhile just touching on that, I guess, idea of increased overmatch and how batteries might be important for that. So I guess as platforms become more battery powered and therefore battery power performance will increasingly determine the capability and range of those platforms. The example shown, I was thinking of one of these sort of small surveillance UAVs, perhaps like the little Black Hornet. And if the range of the Blue Force UAV is greater than that of Red Force, then we will see the enemy before they see us, effectively leaving them blind. But similar examples can be thought of for RF sensing or jamming, and also for increased persistence if your platform can outlast the enemies. Next slide, please. Although I wanted to explore safety a little bit further, since I guess safety is sort of a relative parameter. Mod, like everybody else, wants safe batteries. But in many cases, we also need to maximize performance. And therefore, as ever, everything is a balance and a compromise. For us, a LARP is a key phrase. This means that the risk must be as low as reasonably practical. And this means that in some cases, we use very high energy primary batteries, but in other cases, we still use lead acid batteries. Ideally, we want safe and high energy cells and batteries as well. But we must also take a systems approach. Even volatile cells can be safe if packaged and used correctly, but inherently safer cells will allow more freedom with packaging. I guess where the military may differ from civilian requirements is with the level of abuse batteries might expect. Bullet or fragmentation penetration might be more likely in the military, and shock and vibration may be harsher, for example, off-road vehicles rather than running on smooth tarmac. Next slide, please. So thinking of ideas for cross-sector collaboration and where defence may be a good partner. Defence may be able to adopt emerging technology before it's ready for mainstream markets. And for example, this could be when cycle life or cost is not quite ready for EVs or other applications. Or defence may be able to exploit promising technologies that can't even find a mainstream market. And then thinking about standardization, can defence make use of emerging civilian standards? Or can civilian applications make wider use of standard defence batteries with models already de-risked the technology? In effect, I guess, given a very rugged battery. Some relevant standards might be Defence Standard 6121, which is the generic specification for batteries, and its very many supplements. There's also a whole range of US standards and NATO standards that might be useful. And it would be useful to understand, I guess, the overlaps between commercial and military batteries, and perhaps only minor modifications might be needed to adapt one to the other. For example, putting in a heating pad or strengthening the case. Next slide, please. Today is all about batteries, and these dominate electrical energy storage. I did just want to note that Mod is also interested in other energy technologies such as capacitors, fuel cells, and renewables. I'd be happy to discuss these offline with anybody who thinks they have a promising product. Next slide, please. I believe this slide was shown at an earlier seminar by James Gavin of DSC, but it highlights the British Army is interested in batteries, as in the process of developing a battlefield electrification strategy. The Army accepts it needs better batteries and that solutions developed with other sectors is of interest. And again, it highlights the Army's need for better batteries across the board for vehicles, bases, and for soldiers. Next slide, please. And in terms of exploitation, I guess as I mentioned earlier, defence may be able to exploit products before they meet the needs of mainstream markets. And therefore, I think perhaps defence could be a stepping stone to wider opportunities. For example, defence cell and battery volumes may typically be lower than some commercial markets, allowing a company to grow at a sensible pace and help with that path to scale up. And it's also worth noting that the export market is strong. It's not just the UK MOD that needs better batteries, but NATO and international defence is interested in better batteries as well. Next slide, please. Yeah. So to conclude, I'd just like to say defence is interested in batteries. We are very keen to align with civilian initiatives where possible. Defence has a very wide range of requirements and applications, but ultimately needs that battle-winning capability. And just to finish, I suppose it's worth saying that the cross-sector Battery Innovations Network is a good platform to discover more in defence context, and for defence to better understand wider industry, continue to look together for ways to work together going forward. So thanks for the attention. I'd be happy to try and answer any questions during the Q&A session, but also please feel free to email me if you want to discuss something in slower time later. Thank you very much.
Many thanks, Darren. That was excellent. Thank you so much. As Darren said, if you have any questions, please pop them in the Q&A box. We will be having a Q&A session at the end. And great to hear from so many of you in the chat. Fantastic. I think we have over 200 with us at the minute, which is a great turnout. So lovely to hear from so many of you. I will now move on to Bethan Warby of BAE Systems Maritime Services. Bethan started working at BAE Systems in 2016, working in underwater weapons. During that period, Beth got a first-hand experience on how these products work and how they're powered. Currently, Beth works on products above water, such as small boats, T-45 warships, and Batch 2 offshore patrol vessels. So Beth, over to you.
Hi, thank you very much for that introduction. Yes, I am a graduate mechanical engineer working at BAE Systems in the maritime sector. So I've had the opportunity to work on a lot of maritime products where my knowledge will primarily lie. I'm here to give you some examples of how BAE has used batteries in defence, and I will try my best not to just stick with maritime examples. But I am going to start with maritime. So as Darren mentioned, we use batteries a lot for unmanned vehicles, and on the screen you'll see two examples for underwater unmanned vehicles. So the top one is Archfish, which is used by the US Navy. It is an underwater mine neutralizer system, and it is powered by a lithium-ion battery. So Archfish is quite a small underwater vehicle. The next one is Stingray, which is our lightweight torpedo, and they are launched off of helicopter pads. The one pictured is our Mod 1 torpedo, which is developed from its predecessor Mod 0, and its main power source is a seawater battery. Moving away from maritime, other unmanned vehicles include our Phaser 35, which you might have heard about in the news recently. As you may know, it would be solar powered, and we developed this with Prismatic. But it also has a long life lithium-ion battery, which allows it to maintain flight for up to a year, reaching the upper reaches of the atmosphere. Below, something quite significantly smaller is our Bug drone, which was released recently and developed along with UAV tech. It has a quick change battery, standard battery, and it has a flight time of about 40 minutes. The last one of our unmanned vehicle examples is Ironclad, which is a land-based unmanned vehicle. It is battery powered, obviously, and allows it to run for about 50 kilometers with a set of mission systems that allow that it can be changed in the field. So it can be used for retrieving personnel from the field or scouting missions. This example I'd like to give you isn't really defense based, but it is something that BAE have been working on, which is electric vehicles. I believe Darren did mention in his presentation how the defense sector could help the commercial sector, and this will be an example of how we've developed our electronic systems in order to help the commercial sector with electronic buses. On the screen you see four variants, and they start from electric hybrid and work their way up to fully electric. so that a city would not necessarily have to jump straight into the commitment of being fully electric, and allows it to take stepping stones going towards the net zero target. What I haven't shown on the screen is also how our electronic business is also working on maritime projects similar to the bus projects that you see, where there are, I believe, 3 variants of electronic powered boats that are produced by BAE. All the information that you see in the PowerPoint is available on the BAE website, so if you are interested, feel free to go digging around there. So a bit more about the research that BAE do. We do a bit of research behind electric propulsion, and the idea behind that is to bring developments that already exist in adjacent electric propulsion markets and bring it into the military domain, and that can be used anywhere within the military domain. Another one is structural batteries. This stores the electrical energy within the physical structure of the device itself. This allows personnel to not need to carry around spare batteries, reducing the weight that they need to carry, which is important. To develop the technology, BAE Systems merged battery chemistries into composite materials to be able to mold them into complex shapes and form the structure device itself. This structure can then be charged using renewable power sources such as solar energy. Another company that we've been working with is Williams Advanced Engineering. They are quite well known in the Formula One industry. So we're working to explore how battery management and cooling technologies from the motorsport industry can be exploited into our combat aircraft business unit. Power operational concept demonstration. This was completed at the British Army Training Unit in Kenya. The demonstration used a deployed energy management system, DEMS, which was developed by BAE Systems. The system is a plug-in system between a generator and the distribution system. The generator will charge a battery, which is controlled by the DEMS system produced by BAE, and that system will switch off the generator when the battery is charged. This allows for power on demand, which then means we have increased efficiency and savings when it comes to fuel and maintenance. Submarines. We know that they are not battery powered. However, they do use battery power on them. The main uses for their batteries are for fallback power, their onboard equipment, and emergency lighting. Not a lot has changed with UK submarines when it comes to their battery power in the last however many decades. Submarines are well known for using lead acid batteries, but they also use nickel metal hydride batteries. There has not been any work to be done recently in developing any innovative battery solutions with them. However, I would not rule it out as a future potential. Ship energy efficiencies. A lot that has been mentioned recently is our carbon net zero targets. And this is something that BAE has been working on throughout its business. And one of the ways we are looking to reduce our carbon footprint is through the energy efficiencies of our ships. I believe Darren has mentioned other ways that we are looking to reduce our carbon footprint, such as renewable energy. But one of the ways that we are researching is energy storage. So I've given a few examples of types of energy storage that we've looked into that potentially one day could be implemented onto ships. Along with trying to reduce the carbon footprint on our ships, we are also looking to do the same things with our sites by using more renewable energy on the sites and looking at ways to recycle energy. Finally, what is the future of batteries from BAE's standpoint? As I have shown through the list of products I've given you, energy storage is a key capability in a number of BAE Systems products, including our underwater vehicles and soldier systems. It is also becoming a key part of running our sites and our large platforms. Darren went into a lot more detail about the key requirements for batteries within the defence domain, so I will not stick with this for too long. But as you can see in capital letters, there is safety. Safety is paramount on our systems. When things go wrong, we do not want to put our personnel in danger, which is why it is our #1 requirement when it comes to batteries. And we will need to spend a lot of time proving that they are safe. Along with that comes operational insurance and the lifetime of the batteries. Depending on the product that the batteries will be used on, lifetime may be a key requirement. For some products, such as the ironclad vehicle, we can have a short lifetime battery because we have easy access to the battery and can change it out. However, for some of our larger systems where we may not have regular access to the battery system, we may be looking for a longer lifetime battery that we do not need to regularly maintain. And as Darren mentioned before, depending on the platform or the product, weight and or volume will be a key requirement to the system. So sorry for flying through that, but thank you for your attention. And if you want any more information, feel free to contact me or just go through the BAE website. Thank you.
Many thanks, Beth. That was excellent indeed. It was actually really helpful because sometimes we do discuss about batteries in the X sector, so let's say batteries in defense sector, but until you actually see some practical case studies, sometimes it actually brings it all to life. So thank you very much for that. So I will now like to introduce my colleague Hazel Biggs from Hazel is our defense and security specialist. She manages the KTN Defense and Security Advisory Board, supporting SMEs operating in these sectors and addressing their barriers to success. So Hazel, I will pass on to you to chair our Q&A session. I've seen already lots of interesting questions coming in. So I would just advise everyone, if you could pop your questions in the Q&A box rather than the chat box, it makes it easier for us to see the questions. So over to you, Hazel.
Thanks very much, Nicoletta. Very excited to be here today. And, you know, KTN have a long history working in both defence and security, and our advisory board, as you quite rightly mentioned, is made up of SMEs and primes and government departments. DSTL are part of that, BAE are part of that as well. You know, so if you want to engage more widely in the defence sector, then please come and talk to me and link in. Lots of questions. So I think the first one I'm going to go to Darren here, and it's a question from Tom. Will you be looking at alternatives to batteries like hybrid petrol or electric power packs, you know, and the example given is for UAVs and potential fuel cells?
Yes, very much so. So I think largely it comes down to scalability sometimes. So we are certainly investigating, you know, small engines or larger engines and fuel cells for UAVs. Perhaps they're more applicable at the medium to large scale, and as you get down to the small, I guess, the nano scale, like the bug that Beth showed, then I think it's largely battery technology. So yes, we're interested in all technologies. I think largely for UAVs, it's all about maximizing that endurance, which is really the key metric you want from them, potentially balanced against signature as well. And yeah, certainly sort of small engines and very much fuel cells have a part to play in that. And I've obviously seen quite a lot of the demonstrator platforms where people are claiming quite extended endurances for fuel cell versus batteries on these sort of medium-sized quadcopters. So yeah, it's all of interest.
Thank you. So you know, you mentioned MOD's shift to renewable energy sources. Can you just explain for Carolyn, what's the role of energy storage in that shift?
Yeah, so I think certainly energy storage has got a large part to play. As you know, all government departments have to do their bit for net zero. MODs are different to that, so we're definitely very interested in being more green and reducing our carbon footprint. But also not just for that, there's also the logistical benefits. You know, fuel convoys are really vulnerable, and reducing those, you know, can save lives essentially. So yes, we want to reduce our fuel consumption, and I think Bethan talked about some of the power fob experiences, the system they had at Kenya, and there's some work done in Kenya in the UK as well. And I think looking at the analysis of that, actually energy storage coupled to more efficient use of generators save more fuel than actually using the renewables. Almost the renewables are the icing on the cake, but actually you can save a lot of fuel just by running your generators more efficiently. And the key to that is obviously using energy storage to take out those peaking demands. So energy storage is a key part of reducing fuel consumption, and the same on platforms as well. I think there's base infrastructure there.
Brilliant stuff. You know, you mentioned Darren, and I am going to come to you, Beth, and don't worry about this. I'm saving up all your questions for you shortly, but feel free to chip in if you want to. Darren, you know, you spoke about the growth in electrical consumption, you know, high energy thermal batteries. Can you give some more details, you know, in and around this one, just briefly, to understand a little bit more about that growth in consumption and the impact that it's having?
So I guess essentially when I look across platforms and different systems, and a shame I haven't got any of the graphs, I sort of plotted a graph previously for the power demand of the dismounted soldier and how that's increased over the last, well, since the Second World War. But the same is true for pretty much all platforms. I'm sure Beth knows that from BAE's point of view. We always want more capability, and we always want to put more stuff on our platforms and on our soldiers. And invariably, all that new capability these days tends to be electronic, whether that's more processing power, better sensors, better comm systems, and all that's leading to quite a large increase in power demand. And that's a problem for us, you know. So we really need to have better power sources, even to stay with the same size weight and volume power sources we have today, rather than we're just going to see this massive growth in terms of the weight of batteries and the volume taken up by them to supply the power we need for all the extra capability we want and also we need. So obviously we're not here on our own. You know, enemies and other forces are developing new capabilities as well, and we need to counter those. To do that, we need more equipment, and invariably in the modern world, that more equipment is electronic and electric. So yeah, that's really driving a massive growth in, I guess, the power consumption of pretty much every platform. I've never seen a platform's power consumption go down through time. It only goes up, and that's a problem we've got to address, and hopefully technology can help us address that.
Thank you. So Bethan, I'm going to switch to you now, and I'm going to bounce between the two of you. So Bethan, in your presentation, you gave examples of battery operated vehicles. And what are the design requirements or challenges you face related to batteries and power units in those?
I think that very much depends on the vehicle itself and the environment it's going to be in. I've mainly worked in the maritime industry. I would not know much about our land vehicles and our air vehicles, but with the underwater vehicles, it's very much about the pressure of being underwater, and the distance away from other ships, and also the recovery of the system. In terms of the requirements for power itself, I would have to go away and come back to you on that one, I'm afraid.
No, that's absolutely fine. You know, at the end of the day, we can't have all the answers to every question at this very moment in time, but we will try and get those to everybody. Mm-hmm. In terms of safety, you know, we're talking about safety of batteries. Does it primarily mean the risk of fire and thermal runways, or is it some other safety risk that you were both mentioning in your presentation? So Bethan, should we go to you first?
Fire is definitely a big safety hazard that we will have to consider, and also it depends on the space that it's in. Again, if it's going to be around people, then there's sort of one of the problems that you can get with batteries is overcharging and then producing hydrogen. If there's going to be damage to the battery, what then happens and what further safety risks that imposes. But I think the main thing that we would look at when it comes to safety is if it's around people and what hazards that they bring to the people that it may be around. But yeah, fire is definitely a big one.
Brilliant stuff. Now I've got Darren, I don't know if you want to add anything to Bethan's response there.
I think she's covered the main risk. Obviously, it's that fire risk of batteries that we've all seen of variously smart battery packs sort of bursting into flames. And again, it all depends where you're using it. So in some cases, we might accept the fire risk if you can drop a battery, and we do it in some cases, but then we want to maintain, I guess, any metal flying out from that battery. If you're in an enclosed space, I guess another risk might be some of the harmful gases being liberated when you have a lithium-ion battery fire. So it's all very much horses for courses. But yeah, I think the biggest risk with a lot of batteries is that fire risk, but there are risks associated with them as well. And sometimes it's almost, as I think Beth mentioned in the talk, the reliability risk. So if that platform's safety critical, actually losing that battery, even if it loses safely, is still a risk because you've now lost that capability. And if that capability is life support or something, then again, that's a risk to life. So it's the overall whole piece, I guess, of safety. I say particularly when we're manned.
Brilliant. I'm gonna throw one in from left of field from one of our other panel members. I'm going to drop a minute. I'm interested to see whether or not anyone feels that there's a new battery technology to replace lithium-based batteries to provide a higher energy density over the lithium likely to be commercialized in the near future, or is some form of commercial hydrogen fuel cell more likely? So when do you feel that such a replacement could be commercialized?
I guess I'll start on that one. Yes, so I suppose to replace lithium-ion is a weird phrase because in some respects, I think in my mind, most of the next generation high performance batteries are another version of lithium-ion. And if I knew which one was going to be that next generation battery, then I'd probably invest heavily and retire. So there's lots of promising chemistries out there. You know, the silicon anodes are getting an awful lot of attention. Lithium sulfur is getting a lot of attention. Lithium metal, perhaps enabled by solid state electrolytes, is getting a lot of attention. So those are probably three chemistries that are all vying to be the next contender, I think, in terms of high energy batteries and take us away from, I guess, today's standard lithium-ion batteries, but they're all, in some respects, another lithium-ion battery. And at some point, as those improve, they'll start to impinge on where fuel cells sit. I already see niche applications where fuel cells can make sense, and I think the medium-scale UAVs is a perfect one. I need to probably engage a little bit more on work that's going on hydrogen. I've looked at fuel cells for the last 20 years, and the key challenge for them in the military domain has largely been the hydrogen storage piece. How do you store hydrogen safely and efficiently, rather than just in compressed gas or liquefied? If someone can crack that, then I think that really will enable fuel cells. But it's a hard challenge that's been looked at for an awfully long period of time. But even discounting that, there are already applications where I think a fuel cell with a compressed gas tank would make a lot of sense, particularly on a lot of unmanned platforms.
Thank you. Bethan, any comments from you on that one?
I can't really add to that. I think Darren said a lot there. I think also, again, it just depends on the application, doesn't it, really? There are, with some examples that I gave from BAE, that some products are lithium-ion based, and I don't see certain that it will still, be in circulation, I think, would be my main comment to add.
Thank you. Now, Bethan, you touched on something that's important to all of our hearts, and that's the net zero agenda. How is this impacting, on battery technologies, and how might you see changes moving forward in this particular area, to help us meet our net zero requirements?
Well, I think net zero has driven a lot of what we do. You hear about it a lot. And it is driving a lot of research that we're doing. And it has meant that we are looking into battery technology a lot more. Take the example I gave with looking at improving the efficiencies of our ships and looking to improve the efficiencies of our naval bases or other bases or BAE sites. We are looking a lot more into battery technology and recycling energy, which means we are looking into energy storage. And I do think that means that we are using that type of technology a lot more. And in the future, we will be looking into it a lot more as well. So yeah, I think it's a growing sector.
Thank you. Now, we're getting lots of questions coming in on a theme here. And, a lot of our participants here today, wonderful people that you are always ready to lean in and actually look at some of your specific challenges and help you try and address those. Where would they go to get that fine detail, that granularity in specific challenges that you both have within your respective organisations, and how do they find that information? So let's go to Darren to give Bethan a bit of a rest. Darren, how do they do that? How can they engage, and how can they understand more about your specific challenges and get some detail about requirements from you?
Well, I guess it's tricky. Obviously, MOD is a very large organisation. I would say if anybody thinks they've got something that really can help us and wants some more detailed discussions, obviously, please feel free to contact me or one of my colleagues. I guess if you think you've got a really innovative idea that can revolutionise, I guess, energy for defence, there's something called the Defence and Security Accelerator, which doesn't just obviously look at power sources, it looks at any novel, I guess, game-changing technology for defence. And if you search, DASA, Defence and Security Accelerator, on Google, you should come to the website and how you can submit ideas via that. And unfortunately, mod is a complicated beast, and it's quite hard trying to tease out some of the, I guess, niche requirements, especially when that starts to become close to a competition, and there's only so much we can say. But I would say, just please engage with me, I guess, maybe as the a point of contact to start with, at least to start those discussions, and maybe find another point of contact that can help you find the right person to talk to.
Thank you. Beth, from your organisation's perspective.
I think, yeah, it's quite similar with us as well. We are quite a big organisation. We are one big business that's separated into loads of little small business units. So I think that's why, webinars like this are so good, because then you can get contacts into the company. So I can't give you, a definite one name kind of thing for BAE. But we do have like hubs within each business unit where we look at innovative solutions and new technology that's coming out here. So again, I think it's just contacting someone, and that someone will lead to the next person and the next person. So like Darren has said that he can be the contact for his company. I can do the same for us, and I can give you names that I know, people I've talked to, and I guess that's just with big companies like ours, that's the best way to do it.
Yeah, absolutely. And Nicoletta and this whole innovation network and ourselves and the Defence and Security Advisory Board, we can all help. And that's what we do. We help network and have to be able to allow you to have the conversations with the right people at the right time to get the answers to your questions. In terms of technology readiness levels for structural batteries, what's the level that you're actually seeking at this moment in time?
I think at the moment we're just... I can't answer that definitively because I don't work on it, so I don't know for definite, but I believe at the moment we're at the demonstration stage, but I could be wrong, so don't take my word for it. But that is something I can go away and look at quite easily.
Thank you. Darren, from your perspective?
Well, I think DSTL tends to work at the sort of low to mid TRL levels, but obviously interested in any technology that can help mod. So in effect, if anybody's got a structural battery that saves overall or weight or adds performance to a platform by being deal function, some of the stuff Beth showed, we're interested. So I guess we're interested in anything that can be demonstrated, but even I guess in concepts lower TRL than that, but certainly somebody's got a product higher TRL than that, then obviously we're interested as well, and then can pass it on to DNS colleagues. So I do work quite closely with one of my colleagues in DNS who looks after their small battery group, and they perhaps assess some more higher commercially ready TRL products, and we're always communicating about what we've seen and whether there's anything that they need to assess. So yeah, be interested in anything at any TRL level.
Thank you. So I'm always interested in the magic wand. So for both of you now, just have a think about this. If you had a magic wand that you could wave at this moment in time to solve your biggest challenge in this area, what would it be? What would it be? Beth, and I'm going to come to you first. If you had a magic wand and you could wake up tomorrow and that one key challenge that niggles at you could be solved, what would it be?
Oof. Well, that is a tough question. I mean, an endless supply of energy would be great, wouldn't it? Endless supply of renewable energy that we can just use on demand, that would be great. In terms of batteries specifically, I think for us the main problem is just proving, with the more complex systems and the larger systems, it's more if you could have just this tiny battery that could produce loads of energy, that would be great. I think that would solve a lot of problems, magic wand and all that, but realistically it would just be proving that they work and proving that they're safe in order to be able to implement them.
Thank you. Darren, over to you with the magic wand.
Yeah, I think unfortunately Beth has probably captured all the big hitters. So it would be one of two things: either an incredibly dense form of storing energy, so a magic battery that can store 10, 20 times what we can store today, or alternatively, rather than storing energy, can you just harvest that energy from the environment in a really dense way? And there are schemes being looked at, but in reality, obviously they'll all take many, many years to get somewhere, and a lot of them won't work. So maybe in the realistic phase, a battery that's twice as good as a battery we have today in a relatively short time frame would potentially be a game changer for a lot of platforms.
Brilliant, thank you very much. I'm thinking now we've got a question coming about battery cooling. And I think this is coming to you, Bethan. So what kind of new or innovative cooling technologies do you think have a good scope in the future? And I think some examples we've got there, like immersion or cold plate, etc. Considering the rising demand of high power, more energy dense batteries, etc.
That is a tough question for me. I've not really looked into cooling of batteries, if I'm being perfectly honest. So that is not a question I can answer off the top of my head. You know, especially with my main experience with batteries have been underwater vehicles, and keeping them cool hasn't really been a big challenge. So I can go away and think about that one, but I can't answer that one off the top of my head.
No, that's absolutely fine. We can't answer everything all in one go, and like you said, BAE is a huge organisation. But what we'll do, Nicoletta, we'll try and get some of the answers to some of these questions. Darren, any thoughts from you on this one?
I'm afraid I'm probably not going to be an awful lot more help. Obviously, I know cooling is very important, and as you up the power demand, it's going to be even more important. But I guess in a lot of cases, we'd probably almost leave that to industry to solve for us. So we'd set a requirement for a battery at a certain power level, and whether you manage that by using perhaps higher rate cells that need less cooling, or more energy dense cells that maybe need more cooling, that's almost part of industry's job to package them up in the right way and make sure they meet our needs. So I haven't personally looked at what's the best way of cooling the battery, be it liquid cooled, air cooled, cold plates, heat pipes. All these things have been around, and I guess they all have pros and cons, and equally have to all mate to a particular battery chemistry and pack design to optimize that performance really. So it's all that trade-off, and I'm afraid I couldn't say one's better than the other, and I imagine it's all pretty much horses for courses, depending on how you design that system and whether you're volume or weight constrained or whatever constraints you have. So yeah, a bit of a woolly answer from me, I'm afraid.
Thank you. I guess another one, I'm just going to bounce back to you. I'll keep an eye on the time here. One more. Let's have a little look-see. I was going to ask a question about the work that's been going on around silicon anode batteries. Has there been any work looking at these that you've come across and that you've read and researched into, Darren, or maybe Bethan as well, if you've got an answer to that one?
Well, personally, I've certainly been tracking them, and we're very interested. I guess in my head, I sort of break down silicon anodes into two types. There's the silicon additives, so you put a small amount of silicon into your anode to get a small improvement in performance, and that's useful. And then there's, I guess, the big future jump. Can you go to a pure or largely pure silicon anode, and therefore reap the massive benefits, but also with the challenges that has, obviously the swelling and the cycle life, and potentially the cost of making those systems. I'm starting to see many claims of prototype cells popping out now for very high energy silicon, and I guess the key challenge really going forward can those be made at even an affordable price? And maybe that touches into one of the points I made about, what's the cost of performance, what's the cost of having that battle winning edge? If they can be made affordably, even though they're expensive, there probably is a military market for them before they could be made at a cost that you could actually end up using in an electric vehicle or some consumer systems. So how do we transition that technology that's nearly there into products I can actually go and buy and put on a soldier and put on a platform before maybe they're ready for the EV market? Although ultimately, I guess people are claiming that silicon anodes can be as cheap as carbon and graphite anodes because of higher energy. So we'll have to see how that pans out. But yeah, it's certainly looking very, very promising. But we need to work out that transition to product rather than just prototype, I suppose.
Thank you. Bethan, just give me a funky little wiggle if you want to answer these questions, because I'm going to go into another one. And it's mainly, again, for you, Darren. DMFC got pretty close to commercialisation. So is all the fuel cell focused on hydrogen, or does DMFC still attract interest, in your opinion?
No, assuming you mean direct methanol fuel cell, yes, very much attracts interest. I was playing with one the other week, so we're still in the process of assessing DMFC. I think in the military space, or certainly in the soldier space, that they tend to package down to a sensible size fuel cell, perhaps with sensible size fuel cartons. So there definitely is an opportunity for DMFC. And I guess the weakness they currently have compared to hydrogen fuel cells is the fuel cell plant itself has a lower power density. So for a higher power application, you tend to lean towards, I guess, a polymer electrolyte PEM membrane fuel cell, and that tends to couple better to hydrogen in some way. So I think, yeah, the fuel cell market is still evolving, and I think there'll be parts to play for a lot of the different technologies, and certainly DMFC may well have a part to play somewhere.
Thank you. Beth, any comments on that one?
No. I'll keep it brief. No.
One more question. I think I've got time for one more question. Is there any work going on in printable batteries?
So I think internationally and worldwide there is. I'm aware of some colleagues having a little bit of work with the university who's starting to explore this, but it's a very, very small piece of work. So yes, there is. And I guess DSTL is doing a tiny piece with some universities on that, but there's more, I guess, throughout the UK and worldwide as well. As to whether that'll pan out to be a very, very useful development, I guess it's very early days. But yeah, it's certainly an interesting area, both I guess in terms of making batteries on demand, or whether you can print better structures to allow better access to better battery properties. Or just have the battery shape you want. So it's interesting across the board, and some of it ties into the whole additive manufacturing drive. Again, I guess DSTL and other industries are very interested in additive manufacturing, and obviously if you're going to make a device, some devices need a power source, and if you could print the power source as well, that would be great. But it is challenging, obviously, due to the sensitive nature of a lot of battery and battery materials. But yeah, definitely interesting, and stuff is going on worldwide in that area.
Brilliant, thank you. I've run out of time now, and before I get virtually frowned at, can I just thank everybody for their questions? What I would say as well, from a wider defence perspective, the Defence Security Advisory Board, we liaise with the wider mod sector, and what I'll do is I'll send through some information to Nicoletta that she can send out as part of the outputs for this, in terms of wider defence requirements and linking into the whole bigger picture of defence. But Bethan, thank you. Darren, thank you. You answered the questions beautifully well for me, and I'll pass back to Nicoletta.
Thank you very much. Excellent session, loads and loads of questions. That's what makes a webinar an excellent webinar, I would say. Lots of interaction from the audience. Just on the closing remarks from today, this was the first session out of 3. We look forward to forthcoming sessions on batteries for the maritime sector and batteries for the rail sector. So if you're interested in these, please do join us. I've popped on the chat box the link to our new online hub, which will be available soon. So lots of you are saying, how can we connect with each other? So we're here to help you, but we are also hoping that our new online hub will help you to connect with each other. On phase 1 of the hub, we will be looking to add content, insights, just make it the place to go where you need to find more information on batteries. Phase 2, we will be looking to add more networking features. So hopefully this all will be easier for you in the future. You'll be able to just sign up in the platform and see who else is active and connect with each other. So we do know that this is a requirement from so many of you. You just keep wanting to connect with each other, and we're here to help you. So I've also mentioned in the chat box that at 11:30 this morning, we're launching the Faraday Battery Challenge Investment Readiness Program. So if you're an SME in the battery electric vehicle sector, please do join us for that. Registrations are still open, so you can join us. And just before I close off, Anna, I know you're here today. Sorry if I put you on the spot. I was just wondering, we've had so many questions on batteries, and whether you might want to just say a couple of closing remarks.
Thanks, Nicoletta. Yeah, so sorry, stop my video. Yeah, no, well, firstly, thank you very much to the speakers. It's been and all of the questions, a lot of interest, a lot of questions about the battery technology and what could be on the horizon, and how it can feed into the defense space. So, I mean, as Nicoletta said, we've got the online hub, and we're keen to engage with all of you further, and to really push this technology forward and get it into the applications where it makes sense. So, yeah, very much encourage you all to engage with us, and stay engaged, engage with each other, and there's a lot of exciting developments happening in this space. So it'd be brilliant to see everyone involved in that.
Thank you very much, Anna. And thank you very much again to our speakers. Thank you very much to Hazel for chairing the session excellently. Thank you to my colleague Sheena and Poonam for bringing us here today. And thank you to all of you for joining us in this excellent session. Look forward to seeing you again in future sessions. Thank you very much all, and have a good day.